Now let's move on to the topic of arc flash analysis and calculations. First, let's start from the definition. An arc flash occurs when an electric current flashes over and travels from one conductor to another or to ground instead of following its intended path. And arc faults are typically only present in systems with a bus voltage greater than 120 volts. Normally, an arc cannot be sustained at lower voltage levels. Similar to the arc formed during electric welding, an arc fault must be manually initiated by an event that establishes a path of conduction or by a failure, such as a breakdown in insulation. Picture of distance from arc flash source. So, ibig sabihin kapag mas red, mas delikado yung pwedeng maging damage niyan sa gagawa ng equipment natin. Kapag sa gitna, moderate, tapos dito, slight, tapos medyo mas space or mas safe siya pag nandito sa area ito. And now, let's go to arc fault current formula. So, this is the formula for arcing current or arcing fault current. In under 1 kilovolt system, the formula for log IA is this one. For over 1 kilovolt system, the formula for log IA is this one. Where log is the log 10, IA is the arcing fault current. It should be in kiloampere unit. In the value K is negative 0.153 for open configuration, negative 0.097 for box configuration. The short circuit current must be in 3-phase volts, symmetrical RMS, it should be in kiloampere, or volted fault current. The V is the system voltage, G is the gap between conductor, it should be in millimeter unit. So this is the factors for equipment and voltage classes. This is the system voltage, this is the equipment types, this is the gap between conductors. This is the distance X factor. So this one, we can use that in the formula in the further slides, and also this one. So incident energy formula, the formula for incident energy En is this one, where log En is this one, the formula for log En is this one. Incident energy E for system voltage under 15 kilovolt system, the formula to be used is this one. For system voltage over 15 kilovolt system, the formula to be used is this one. En is incident energy. CF is calculation factor, where 1.5 for 1 kilovolt. If it's less, above 1 kilovolt, the CF or calculation factor is 1. D is the working distance from arc source. It must be in millimeter unit. T is the arcing fault duration. It should be in seconds unit. X is the distance exponent that can be seen in the further slide, in the previous slides rather. Arc flash protection distance formula. So the B is the distance of the boundary from RC point in millimeter. For system voltage under 15 kilovolt, this is the formula to be used. For over 15 kilovolts, this is the formula to be used. EB should be in joules per square centimeter. For example, 5 joules per square centimeter. So hazard risk category matrix, this is the minimum incident energy to its maximum value, and risk category, the minimum rating of PPE. Now this is the recommended personal protective equipment, in short PPE. This is the risk category. This is the corresponding PPE to be used in said risk category values. Now let's go to our flash calculation. Our task is to solve for transformer 2, which is LBSD2, or low voltage switch gear 2. In branch circuit number 1, we have RFCJB. In first step, we determine the volted fault current or short circuit fault current. Our short circuit fault current is 44.234 kiloampere. In next step, we determine the arc fault current or arcing current. This is the formula to be used. And this is the variables. G in millimeter is 32 millimeter. K equals to negative 0.153. K1, negative 0.555. K2, negative 0.113. Factor is 1.5. Our RC time in seconds is 0.032 seconds. The distance is 457 in millimeter. Our distance exponent, or x, is 1.473. Our system voltage is 0.4 kilovolts. Now we substitute the variables to the formula. We have the result of 1.19972. Substitute this value to the previous formula, which is this one. We have 10 raised to 1.19972 is our RC current is 15.84 kiloampere. Next step, we determine the incident energy En. So this is the formula. The formula for log En is this one. Substituting the variables, we have 0.66414. Substitute this to the previous formula, which is this one. 10 raised to 0.66414 is 4.665 joule per square centimeter, or 1.115 calorie per square centimeter. In step 4, we determine the incident energy E at working distance. So this is the formula. Substituting the variables again, we have the final result of 7.168 joule per square centimeter, or 1.713 calorie per square centimeter. In step 5, we determine the arc flash boundary dB in millimeter. The value of EV is 5 millimeter. So this is the formula for dB. Substituting the variables we already have, we have the final answer of 583.589 millimeter. For circuit number 2, RMC3B, our first step is to determine the voltage fault current, or short circuit fault current, which is 36.787 kiloampere. In step 2, we determine the arc fault current. So this is the formula to be used, and this is the variables to be used. Same with the previous one. I substitute the variables. We got 1.13661. Substitute this variable. This result to the previous formula, which is this one. 10 raised to 1.13661. The RC current equals to 13.697 kiloampere. Our third step is to determine the incident energy En. So this is the formula. The formula for the En is this one. Substituting the variables again, we get this one. The result is 0.6007. Substituting this value to this one, 10 raised to 0.6007 is 3.987 joule per square centimeter, or 0.9529 calorie per square centimeter. In step 4, we determine the incident energy E at working distance. So this is the formula. Substituting the variables to the formula, we get this one. The result of this formula is 6.126 joule per square centimeter, or 1.46 calorie per square centimeter. In step 5, we determine the arc flash boundary dB in millimeter, and the value of EV is 5 millimeters. So this is the formula. And now we substitute the variables. So this is this one. The final answer is 524.5696. In branch circuit number 3, we have MCC, or motor control center. In step 1, we determine the voltage fault current, or short circuit fault current, which is 35.206 kiloampere. In step 2, we determine the arc fault current, or RC current. The formula to be used is this one and this one. The variables to be used in this calculation is this one. Same with earlier. So now we substitute the variables to the formula, which is this one. The result of this one is 1.12158. Substituting this to the previous formula, which is this one, 10 raised to 1.12158. We got the arcing current of 13.231 kiloampere. In step 3, we determine the incident energy En. So this is the formula. The formula for log En is this one. Substituting the variables, this is the formula. Now, the answer to this formula is 0.584. Substituting this value to this one, which is 10 raised to 0.584. The answer to that is 3.84 joule per square centimeter, or 0.918 calorie per square centimeter. In step 4, we determine the incident energy E at working distance. This is the formula to be used. Substituting the variables again, we got 5.9 joule per square centimeter, or 1.41 calorie per square centimeter. In step 5, we determine the arc flash boundary dB in millimeter. The value of EB is 5 millimeter. This is the formula to be used. Substituting the variables again to the formula, we got 511.36 millimeter. Now let's move to the last branch circuit number, which is number 4, RMC2B. In step 1, we determine the voltage fault current or short circuit fault current, which is 25.574 kiloampere. In step 2, we determine the arc fault current or the arcing current. This is the formula to be used. And this one, this is the variables. Substituting the variables to the formula, which is this one, the result of that is 1.01216. Substituting this value to this, 10 raised to 1.01216. Our arcing current is 10.284 kiloampere. In step 3, we determine the incident energy En. So this is the formula. The formula of log En is this one. Substituting the variables, which is the one, the result is 0.466. Substituting this value to this one, which is this one, 10 raised to 0.466 is 2.925 joule per square centimeter, or 0.699 calorie per square centimeter. In step 4, we determine the incident energy E at working distance. So this is the formula. Substituting the variables again, we got 4.49 joule per square centimeter, or 1.07 calorie per square centimeter. In step 5, we determine the arc flash boundary dB in millimeter. The value of EB is 5 millimeter. So this is the formula again. Now we substitute the variables to the said formula. The result of that is 425.088 millimeter. So this is the summary of arc flash computation in low voltage switch to 2. So this is the loads. This is their short circuit current. This is their arcing current, the incident energy, the arc flash boundary, the PPE class required. This is the type of circuit breakers to use. This is the RC time, and this is the circuit breaker CAIC rating. So this is the group member of group 4. I am Glacian Joshua S. Puna, the group leader. My members are Jidan Paul T. Alibosa, Shane Benedict D. Barbosa, Arwin Joseph Garcia, Kathleen M. Lonyosa, Jasmine M. Quinto, Luis Antonio R. Reyes, and Joyce Ann A. Veranga. Thank you.